Set theory is a branch of mathematics that involves collection of objects. When objects have a common characteristic, they form a set. In describing a set, we use language that is clear so that there is no doubt in identifying its members. A set is a clearly defined collection of objects. Some examples of sets as follows: the set of vowels of the English alphabet, the set of planets in our solar system, the set of black cars, the set of boys on the school's football team, and the set of girls in Form 5 at school. The first two examples are readily identifiable and can be listed. The set of black cars can also be identified even though we do not have information about all its members in terms of their location. What is important is that we can differentiate between the cars that belong to the set and the cars that do not belong to the set. The members of a set may be unknown, but once the description is not vague, it is well defined. When describing sets, we use curly brackets to replace the words "the set of." For example, the set of all the whole numbers from 1 to 10 inclusive is written like this, where the words "the set of" is replaced by curly brackets. The set of figures bounded by 4 straight lines is written like this, and the set of multiples of 5 is written like this. Let us look at the example. Does each of the following describe sets? A. Tall girls in Form 6. B. Girls in the school choir at Valley Government. C. Men who can sing well. And D. Boys who are good at sport. Only B is clearly defined, and hence only B describes a set, which is girls in the school choir at Valley Government. A, C, and D that describe tall or who can sing well or good at sports are all relative terms and not clearly defined. The statements A, C, and D can be reworded to describe sets. For example, instead of saying tall girls in Form 6, we can say girls who are over 160 centimeters tall. Instead of saying men who can sing well, we can say men who have auditioned for the church choir. And instead of saying boys who are good at sports, we can say boys who are members of their school cricket team. Each of the above statements is now clearly defined and describes a set. A set must be defined in such a way that there is no hesitation in deducing whether or not an object belongs to the set or does not belong to the set. Every collection is therefore not a set. A set is usually named using a capital letter. If we are speaking of the set of students in a school who study Spanish, then we may choose to name the set S, where S is described as follows. S is the students at our school who study Spanish. The following are examples of sets named by letters of the alphabet. A is multiples of 10. B, words that begin with the letter P. C, members of the school's football team. And D, red sports cars.
Now let's talk about the number of elements in a set. The number of elements in a set, let's say A, is called the cardinality of the set, and it's expressed as n of A. For some examples, the set A containing M, N, and P has 3 elements, or n of A is equal to 3. The set B, containing cherries, plums, mangoes, and oranges, has 4 elements, or n of B is equal to 4. Finite and infinite sets. If a set is comprised of a countable number of elements, it is called finite. If a set has infinite number of elements, then it is called an infinite set. It is not possible to count the number of elements in an infinite set. Hence, it is not possible to state the cardinality of an infinite set. Even though we may think of the cardinality of an infinite set as being infinity, infinity is not really defined as a countable number. The null set, or the set with no elements, is considered to be a finite set and has a cardinality of 0. So let's look at some examples. An example of a finite set may be the vowels in the alphabet, that is A, E, I, O, and U. Now, as you can see, there's only 5 elements in the set, and so the set is finite. An example of an infinite set may be the multiples of 3. There are countless multiples of 3, and so the set is infinite. Notice that in this set, there are 3 dots at the end that indicates that the elements of this set continue forever.